Hello. In this video, we discuss a instrument called cyclotron. It is actually a particle accelerator to obtain high energy particles like proton, neutron, alpha particle, like that. And why this is called cyclotron is because in this particular case, the particle is accelerated by making it to move in cyclic paths. Okay? And this is devised by Lorentz and Livingston. Now let us see what's the principle behind the working of cyclotron. The principle is that a charged particle can be accelerated to high energy by making it to pass through the same electric field again and again with the help of a uniform magnetic field. So here, two fields are required. One is electric field and the other is magnetic field. Now let us see the arrangement. These are two metallic Ds, hollow D-shaped system that the particle can go inside and come out. Kept facing each other such a way that the contour makes a circle. And these two wheels are connected with a low alternating voltage with a high frequency. This is an alternating voltage with a high frequency. It's connected so that can supply an electric field between the gap of that D. And that electric field will be oscillating. In one half of AC it goes like this, and the other half the field will be like this. So the electric field here is an oscillating one. And the two magnetic poles are kept such a way that the whole system will be inside that uniform magnetic field supplied by these two magnetic poles. And that magnetic field, you can see it is vertically downward. So this is the experimental, the setup arranged for accelerating the charged particle. Now let us see how the acceleration is taking place. Assume that I am trying to accelerate proton. That proton, I place it exactly in the center of the circle made by the two T's. The moment when you keep that over here, suppose this is positive and this is negative. Therefore, there is an electric field along this particular direction so that the static positive charge will be experiencing an electric force and that goes along the direction of the field. So it starts moving along this particular direction and by that it goes inside the D. It goes inside. Inside the metallic disc there is no electric field possible, but there is magnetic field possible. So the charged particle is now entering into a magnetic field perpendicularly so that we can apply the left hand rule to find the deflection of the particle. So field is downward and proton is moving along this way and therefore the force will be like this. So the particle inside the D will be going in a circular path along this way. As it moves along a circular path, it has to come out from that D. As it come out from this D, suppose this is positive and this is negative. The next half comes. So between the D, there is electric field now along this particular direction. The particle accelerates with that electric field and enter into the next D. Inside that next D, only magnetic field is there, but it is entering with a greater velocity, so it moves in a greater circle path. As it comes out, the polarity changes once again, and the electric field is along this direction. Like that, the change of polarity of this field and the coming out of the particle are now synchronized, and you can see this process continues and it goes in a larger and larger circle, and as it comes to the maximum, it will be coming out through the window provided. So the particle will be shooting out through the window provided here. Okay? So this is how the action is taking place. But then we found that as the particle comes out of one D, the other D will be oppositely charged, so that the acceleration takes place. For that, there is a resonance condition required, that is, the frequency of the AC supply will be equal to the frequency of the cyclotron. That is, the particle frequency is called frequency of the cyclotron, and the AC frequency. These two are equal, then the resonance takes place and the acceleration is possible. Okay? But if anybody asks what is the working of the cyclotron, you can write only one sentence that the electric field existing between the D's accelerates the particle, and the magnetic field will be taking the particle to go in cyclic path. This is what actually happening here. Okay? Now, what about the frequency of the cyclotron? Possible in this one. As you see, the particle is now going in an expanding circle. We cannot take anywhere in between. You will be taking the calculations based on the maximum circle possible, that is just before it is coming out through the window. In that case, you can find m V max square divided by R max. Centrifugal force, it's been experienced by the particle. The maximum will be equal to Q into V max into V. Out of this, you can have V max is equal to V max is equal to, what do you get? V max is equal to 1 V max from this and this goes. V max is equal to Q into V into R max divided by mass of the particle. Now, what is the time period of motion of the cyclotron particle? Time period T will be equal to 2 pi into R max, that is the maximum distance covered, divided by the speed with which it is covered. So when you substitute the values over here, you can find that this is equal to 2 pi m divided by Q into B. So time period is not depending on the radius or the velocity is independent of that, and therefore frequency of the cyclotron nu for the cyclotron will be equal to q into b divided by 2 pi m. This is the equation for cyclotron frequency. See the equations? This all we discussed already, so no confusion further. Now, the next question is, what is the maximum energy possible for the particle which is getting accelerated? Now, the maximum energy possible will be half m into v max square. Substituting this v max as this one, you get the equation as q square v square r max square divided by 2m. Now this is the equation for kinetic energy of the particle possible from the cyclotron. Now there are certain things to be noted that the r max we define here is nothing but the radius of the circle or the radius of the d you are taking. And q and m defines the mass and charge of the particle. So when you select proton, it is having a different charge and mass. Therefore, by fixing the value of r, the shape of the d or size of the d and the magnetic field, you can define what is the kinetic energy maximum. Or you can decide the kinetic energy first, how much energy you require. Accordingly, you can set the d and the b for a given particle and construct the cyclotron. Alright? And remember one more thing. This is used for accelerating charge in the particle only, and also the particle must be a little bit heavy. Electron, you cannot accelerate using this one to a high energy, but it can be accelerated, but there is a ceiling required for the speed. Okay, so this is used only for accelerating charged particles like proton, neutron, alpha particles, like that. Alright.